Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take yet another look at our P2 sample P2 project. Remember that this project may not be necessarily the one that you are doing this semester, but rather the project is supposed to demonstrate some of the key components of your current P2. And if anything, you should be able to follow along with these steps and make your P2 work. Now, a couple of things to note here is that you should have a set of instructions for this particular project, this sample project, as well as sample input and output, the function signatures themselves, and so on. So this video assumes several things. It assumes that you've already worked through the problem. In other words, that you've got your projectile 1D version 1, projectile 2D version 1, and simple supported beam all working. Now, even though this may not be your current P2, I would really encourage you to go ahead and work through this relatively straightforward example before you continue, because this demonstration will make a lot more sense. So, assuming that you have successfully created your source file and then you have successfully built it, you should now have a p2.exe. And to show you what I'm talking about, I'll come over here and you'll see that I have a p2.exe. Now, from the first video in this series, when we did the setup, we sort of just blindly went through and we created each one of the functions, and then we put a printf statement in the top of each one of the functions. The idea was essentially to make sure that we had wired up our executable correctly before we actually wrote any code. And this is a really good process to do, and we're going to continue this on through the semester, sort of embracing this top-down design, if you would. But you'll also remember that we left all three of our functions uncommented, which would effectively mean that we were calling all three of our functions. Now, the point of this part of the project is twofold. Is number one, to show you that this is a bad practice for a number of reasons, to keep adding more and more functions into an executable without some way to control their behavior. And then we can see how maybe we can change some of that behavior by changing the file name, etc. But also what we want to do in this particular video is we want to focus on input and output files, in other words, piping behavior. And then lastly, we want to go ahead and create a batch file. So if anything, what we want to do is we want to focus on how we would test our executable. And so the very first thing I want you to do, if you're on Windows machine, you can simply go ahead and type explorer.exe and then follow that with a space and a period. And what it will do is it will open up Explorer in your current directory. And so I'm going to slide these over to the side on my second monitor. But I would encourage you to keep that up because we'll be bouncing back and forth between those. So the first thing that we want to do is we want to notice that we have all three of our functions uncommented. So right now, if we were to build this and run it, we would simply get prompted first by the 1D problem, then the 2D problem and the beam, which would probably be pretty annoying, especially if you only wanted to do one of them. And so to combat this, what we're going to do is we're simply going to turn off or comment out the 2D and the simply supported beam. We're going to build it. And now the only thing our executable will do is it will run the 1D version 1. And since those other two are commented out, they'll never get run. Now, if you go back to the instructions, you'll notice that I've talked a little bit about this scenario and that I've asked us to create three different executables. Well, to accomplish this, what you're going to do is you're simply going to copy the executable as I've requested. And once again, for your project, it may be a little different. And then you come over here to Windows and you simply rename your existing executable, the p2.exe, to the name that I have provided. Now, if we come over to the command window, we can actually run your projectile 1D version 1 as if it was the only thing that was in the executable, which in fact it is, because it's the only thing that has been left uncommented. So in this case, we're just going to run it one more time to prove that it works. Even though we've renamed it from P2, it still functions as if it did when it was P2. So we've just changed the name of the executable. Now you're probably wondering, how do we do that for the other ones? Well, we follow the same process. We simply comment out the 1D, uncomment the 2D, build. And then once you've successfully built it, you go back and you find in the instructions the name for the executable that corresponds to, in this case, the 2D version of the problem. You come back over to the Windows folder, MinGW folder. You'll notice that up popped another p2.exe, essentially the results of our most recent compile. And we simply then change the name of that one to 2D version 1. And you can prove to yourself once again that you've accomplished what you wanted to by simply running the 2D version 1. And sure enough, if I enter in a velocity followed by a theta for the 2D version, you'll see that I'm now running the 2D version of the problem. And you can actually notice here, this is another reason why it's very helpful to put that first print statement in there, because it tells us what we are doing. I think at this point, you could probably guess what the third one is going to look like. We're simply going to uncomment the third function, build it, and once again, there pops up another version of our p2.exe, except this time we are simply going to rename it to simple supported beam version 1. Now, as I mentioned, there's multiple points or purposes behind this video. First and foremost is to show you that this is the wrong way to go about doing things. It would be highly unlikely that you would simply recompile an executable only to rename it, although there are scenarios where you might find yourself doing it. We're going to investigate another way to go about doing this that is going to be much, much more efficient. The second purpose of this video, though, is to demonstrate piping. And so what we're going to do now, if you go back to your instructions, you'll notice that I have provided a text file or requested a text file for batch input. And what we're going to do is for every one of our executables, we're going to test it in an automated fashion by providing the value that you would otherwise provide on the console or on the command line. This becomes really useful when your program starts getting larger so that you don't have to stop and constantly enter in the values when you're testing it. And so to understand what we're going to do here, I'm going to start off with this projectile 1D version 1. And I realize that this particular function and executable is kind of simple. It really only accepts one value, but that's okay. Our other ones accept more values, and hopefully it'll start to make sense to you. And so the first thing you want to do is you want to go ahead and create new text document and give it the name that I have specified in your version of P2. Now, in this case, I have made the text file match in name to the executable. And in case you have not yet done so, you need to make sure to go to View and turn on the file name extensions, or this particular portion is going to get really confusing. Now, this text file is blank at this point. You can double click on it or you can drag and drop it into NetBeans. But effectively what we want to do is we want to put in the value that we would have otherwise entered on the command line. So in other words, where we are prompted for the height, we simply want to put that value, or 100, in our projectile 1D version 1. And so I'm going to go ahead and finish this out and run it. You get the results that we got earlier. But now back to the text file, we go ahead and save the text file. And instead of simply running the executable like we did just a second ago, what we want to do now is we want to pipe to it using the less than sign, the name of the file that we just created. In other words, the projectile 1D version 1.txt. And so what this will do is it'll take the contents of the file, and every time it sees a scanf, it will attempt to put the value in that scanf or respond to that scanf from the executable. And so you can see here that in one fell swoop, in other words, we didn't have to type in any additional information, we could now automatically run our projectile 1D version 1. We didn't get an additional prompt to enter in the 100, and yet it still ran. And you can prove that this works just for a little bit of a sanity check. I'm going to change this value to 200. And I'm going to rerun it just by simply hitting the up arrow. And you'll notice that now I have a different y-init corresponding to the file. Well, we can do the same thing now for each one of our executables. And so we'll start with the projectile 2D version 1. And the key thing to remember with this particular example is that it had two input arguments, the v-init and the theta. And so what we would want to do here now is have two lines. So if we drag and drop our text file into NetBeans, we put on the first line the v-init, and on the second line, the 0.7854 that we said corresponded to approximately 45 degrees. We go ahead and save this, and we can come back over to our command window. We'll run our projectile 1D version 2, our projectile 2D version 1, and we pipe to it now the projectile 2D version 1.txt. It'll take you a little time to get used to the filing naming convention or the file naming convention. All right. Well, if we run this, you'll notice that it automatically plugs in those values for the y-init and our theta based on the file. Once again, you can change the contents of the file to prove that you are in fact working with the file as opposed to something else going on behind the scenes. So if we rerun this, you'll notice there is my v-init of 200. For our last one, we simply do the exact same thing. And so we'll create another text file. We'll come over here to our folder, name the text file according to your version of the P2. And remember that we provide 3 pieces of information in our third function. And if you need a quick reminder, we'll go down here. We provide it first with the load, then the length, and then the location. So if you want to follow along with our earlier example, we'll do 100 for the load, we'll do 10 feet for the length, and we can either do the 0.4 or the 5 feet, doesn't really matter. We'll keep with the first example of 0.4 feet. And at this point, we can come over here. We can run our simply supported beam version 1, and we can pipe to it the simply supported beam version 1.txt. And you'll notice I'm typing this pretty quick. It's not that I'm doing anything fancy or anything like that. I'm just simply leveraging the autocomplete by typing in the first few letters of the file, whether it's the executable or the text, and hitting tab. At this point, we, once again, are not prompted. You see all of the printfs, but basically what we're doing is we're piping the values into the scanf so that we don't have to have the extra burden or the time associated with manually entering in those values. Now, the logical next step to this is to be able to automate the entire process. And the way we want to go about doing this is first understanding how we can collect not only the input arguments and send them to the executable, but we also can collect the output arguments. And so what I'd like to do is I would like to focus on the output, if you would, for our projectile 1D version 1. And let's not call them output arguments as much as just simply the output that's printed to the command line. So what we're going to do is, in addition to calling our 1D version 1.executable and piping to it the 1D version 1.txt, or in this case, the value of 100 or 200, depending on where you've left it, I want to turn around and I want to pipe using the greater than sign to a p2.txt. And what you'll see will happen here is nothing. Well, not exactly. Plenty happened, but we just didn't see any of it. And so much like we didn't have to type in the values for the scanf prompts, now what we're doing is we're piping all of the print statements to this p2.txt. If you go over to your MinGW folder, you'll see there is now a p2.txt, which you can either double click on or simply drag and drop into NetBeans. And you'll see that what would otherwise have been printed to the command line or console is now put into a file. Well, we can do this with each one of our executables. And so what we'll do is we'll start off with our projectile 2D version 1. We'll pipe to it the projectile 2D version 1.txt, and then we're going to pipe the contents of that to our p2.txt. And if you run that and you come back over here to NetBeans, you'll notice that we have overwritten or lost the first example. And essentially what we've done is we've overwritten the contents of that p2.txt file, which that's perfectly fine if that's what we wanted to do, but let's try something different. We're going to go back here to the console one more time. We'll go back to the first example where we're piping the 1D version 1 to p2.txt. And you'll see there's our original version in NetBeans. And this time around, I'm going to modify just ever so slightly the 2D example, and I'm going to use 2 greater than signs. And what you'll see now is it appends the second example or the second results to the text file. And so what you're going to discover is that a single greater than sign overwrites the file and 2 will append it. And so the logical next step from this will be to run our simply supported beam executable, piping to it using the less than sign, the simple supported beam version 1.txt. If we use a single greater than sign, we risk overwriting the p2.txt. And so instead, what we want to do is use 2 of them and pipe the contents to that p2.txt. And now what you've done is automated running all of your input as well as your output. And now we're almost done. We've got one last step in this automation process, and we'll get plenty of opportunity to do this in the future, but you do want to practice this as we go along. And what we'll do now is we'll come back to our MinGW folder, and we're going to create one more file. And we go here to New, and we can create it as a text document where we're going to change the file extension from txt. In this case, we're going to call it p2.bat. Windows is going to warn you, do you want to do this? You select yes, and then you can drag and drop that text file to NetBeans. And what we do now is we come over to the command window, and everything that we had manually run or typed in earlier, we simply copy and paste to this batch file. So notice I'm doing the 1D version 1. I'm going to very carefully come in here and do the second version of our 2D, where we use the double greater than. And then we come back here one last time and we grab the simply supported. Now, we can get this fancier as we go along. You'll see how we can add in some comment fields, some notes, and everything like that. But once again, that's more sophistication than we need. And what we want to do now is we simply want to save the p2.bat. Now, I'm going to go ahead and clear the screen. And you'll notice if I type in dir, I've got not only the p2.txt, but there's our batch file, etc. And what I'm going to do is I'm going to actually delete the p2.txt. You can do this in Explorer as well, but if you type dir, you'll see I just have my batch file, my input text files, and my executables. If I run my p2.bat, well, not a whole lot happens, but you'll see that every single one of the commands that we had typed into the batch file are now being displayed on the console. And then more importantly, if I type in dir, there is our p2.txt back, which we can take and look at inside of NetBeans, and you'll see that we have automatically run all of our executables at once. And I think you would quickly agree that this is a much, much faster way of testing your executables. Now, just as a little bit of a side note, this actually gets us into test-driven design. And so fundamentally what you can do is you can write your batch file before you even start writing your executable or the source code for your executable, much like what we did in our first video with this project, where we wrote all of our functions and simply put a print statement in each one of the functions before actually writing any real code. So what you can do is you can essentially wire up all the functions in your executable, build your batch file just simply to confirm that you have everything working before you actually start writing on any of your code in any of your functions. So hopefully this video helped. As always, if you have any questions or comments, don't hesitate to ask, and thank you for watching.